So student, let's start with the Delcam POWERMILL. Initially we have some basic introduction about the POWERMILL. For that, what Delcam POWERMILL is? It is a software developed by Delcam company for machining or toolpath generation and convert it into CNC programming. It is also called as a CAM software. What is CAM? It is a computer aided manufacturing. It is a software used for creating the toolpath and program of 3D complex geometry. It is used in toolroom industry, die mold and pattern making industry. It is useful for such nature of jobs. So these are called as the die mold patterns or complex geometry. Before to start, we must know what is the syllabus of the Delcam POWERMILL. So here we are going to cover, these are the topics like number 1, model importing, IGS conversion, model orientation, model analysis and measurement. The next topic will be work plane creation, work plane at the corner, work plane at the center, work plane at the whole center. Third one will be the block definitions or raw material defining. Here with the type that is called as a box type, cylindrical and boundary types. The fourth one will be cutter creation, tips radius cutter, end mill, ball nose cutter and holder assembly and collet assembly. These 4 topics we will try to cover in this video. So let's go one by one. So let's call the model first. So to call the model, you have to click here in the file, then imports, import the model. So click on this tab, it is called as a model tab. So here it is a list of the model given here. With that you can select any model. Suppose I select this headlamp or this mouse or this power tool. So preferably I use this model that is called as a cowling. So click here, opens. So now the model will be here. So this is called as a shape, model or design. So we have to create cutting process for this model. So this method is called as a how to import the model. Once again, file, suppose close this one. I close this. Do you want to save? I say presently no. Again I want to call some another model or same model. So keep in mind the process. Firstly you have to click here in the file, then import model, then click on the tab model. Then here it is a list of model. If you know the name of that model, you can simply type the name and open that. So this is called as a model importance. The second one, model supplied by the customer. So we don't know about the size of that model. So we have to firstly measure that model. And to measure that model, I will click this view bar. Here it is called as a view bar. With that I will prefer top view. This model, it is in the shade. I will prefer it in a wireframe. So to just switch off this. So this is called model in wireframe. This is called model in shade. So I prefer the model in wireframe. Now I want to measure this point to this point distance and this point to this point distance. To measure this, we have to click on one tool here. It is called as a measure tool. So if you click it here, measure, then there are so many options to measure. I want to measure the distance. So initially I will click distance between. So this tab is called as the distance between 2 points. Click here. Now if you want to measure this distance, click one point here, click another point here. So it will show that distance of 100 mm. Suppose I want to measure the radius of this hole. So I will use, there are 3 options, that is radius using the 3 point or diameter. I prefer this diameter option. Just click on this circle entity, you will find it will show the diameter. So in this way you have to measure the distance or radius and diameter. So I measure that. Why to measure? So that you can come to know the size of this model. Accordingly you can plan the raw material and you can plan the tools. The next step will be creation of the work plane or creation of the job zero. So creation of the job zero, here in the language of CAM it is called as a work plane. It is mentioned here in the exposure, work plane. So right click on that work plane. There are then click here on the create an oriented work plane. There are so many methods to create a work plane. Initially with my first video we are trying to give the basics ideas about. Then there will be a separate video on creating the block in a different way. Sorry, work plane in a different way. So I will prefer this option, work plane at a point. Suppose I want to create a zero at this corner. We have to simply click here. The work plane get developed here. But it is called as the inactive mode. To activate it, you have to just click here. In the work plane, the plus button get added here. So click that plus button. With that, there is a number 1. Work plane number 1 is given there. So click here, right click here, and activate it. So now you'll find this get activated. So we create the work plane at these corners. The next thing is you have to apply the raw material that called as a block in the language of the CAM. So to create a block, you have to click here on these box type buttons. So here it is called as a block. In the block, there are so many methods to define the blocks. With that, box, picture, triangle, boundary, cylinder, and so many others. But initially, being as again for the beginner, we prefer three options, that is box, boundary, and cylinder with this video. So click here in the box and press the button calculate. You will find a material layer get generated around this model. But this is the model with exact size of model. Whatever the size of model, you will find the material layer will be accordingly. That called as a cut to cut block or block of model size. But in actual, the material may be plus. So if you want to show that plus material, so here the word written expansion. With that expansion, you have to write your expansion value. Suppose right now I am writing 10 mm. So 10 mm will be the expansion, and I will press the button to calculate. So if you press the button calculate and check here in the view, you will find some extra material layer is there in the different view. Extra material layer is there. So this is called a block with expansion. Suppose I don't want that expansion, I will again make it 0 and press calculate once again. So this is called block with box type with some expansion. Sometimes that block or raw material will be in a round shapes. So for round shape job, you have to use the option that called as a cylinder. In the cylinder option, we have to show the block in a round shape. So here you will find the block is a round shape, but definitely it is not for such types of job. It should be for the round material only. So in this case, suppose you want to add the expansions, again you have to add the expansion, but that expansion will be diametrically. If you check out its view, you will find it is a expansion is a diametrically. Then third one, it is called as a boundary type blocks. In the types there is option boundary type. What is that boundary type blocks? Suppose I want to create material only to this area. So select that area first, then come to the here exposure, right click here on the option name as a boundary, create boundary and user defined. Where is that user defined? It is defined on the model, so you have to use this option model and press the accept button. Now just check there is a one white layer over there and you want to create a block around this white layer. So here change the option, keep it boundary types and press the button calculate. You will find your material is of that boundary shape. So these are the three methods. One is called as a box, second is called as a cylinder, third is called as a boundary type. The rest of the will be in another separate video. Then press these accept buttons. Sorry, suppose now I want to change, I want to keep it box type and press the button calculate. The next thing will be you have to show which tool you want to use. So you have to make a list of your tools. So to create the tools, you have to click here in the explorer. The tool button is there. Right click here, press the button create tool. There are so many types of tool. Again in the tool room industry modality, most preferred tool will be tips radius cutter, end mill cutter and ball nose cutter. These three cutter will be available there. I can show you the types of tool here. So here you will find the list of the tool get used. So these are the tools. This one is called as a tips radius cutter. This is another tips radius cutter. This cutter is called the 52R6 is the size of that cutter. This is 25R.8. It is a 0.8 is the radius here. Then this one, third one is called as an end mill and the fourth one is called as a ball nose or profile cutters. Now how to create that tools? So here in the explorer, click the button tool, right click, create tool. Suppose I want tips radius cutters, I will click here tips radius. Now here you have to define what will be the diameter of that cutter, then what will that insert radius and name of that cutters. Suppose I write, I want that cutter with the diameter 52 with the corner radius 6 mm and the name of that cutter is 52R6. And here you have to add number of flutes. Number of flutes mean number of inserts. Suppose standardly that cutter with the 4 inserts. So this is the tool assembly. We have to add shank, holder, and even you can set the cutting data here, but that will be taken in the another video, specifically how to create a tool assembly that time. So I just press the close here. You will find on the screen a tool like picture will be there. So this blue is my model. This yellowish is like my raw material, and this yellow is called as a tool here. Now the next thing is, suppose I want to create another tool, create tool, suppose end mill. So here again I have to define what will the diameter of that end mill, suppose 12 mm. Length we will set later on. Then define the name. So normally we write the name for the end mill 12 EM. EM means end mills. No need to write the fluids and all these things for these types of cutters. So here you will find end mill type cutter will be there. The next one, that is tool, create tool. Suppose I want to use the ball profile cutter. Here ball. Then you have to define what size of ball cutter you want. Suppose 16 mm. Label it 16 EM. 16 EM and press close. So now you will find the tool get created. So we have created in our list, you will find 3 tools there, 52R6, 12 end mill and 16 end mill. So here with this video, we cover something like import the model, measure the model, work plane creation, block creation and tool creations. Looking at the length of the video, we are splitting the syllabus in different video. So I request all viewers, student to watch video in a series. So next video will be on the topic how to create the tool path, how to apply the speed field, then how to simulate that tool paths. So watch the next video. Thank you very much.